Hey, folks. Surprise. You could just tell that I'm using the origin. Hey, cool. Hello from Campbell River. That's awesome. This is M13, the Great Globular Cluster in Hercules. So we've got pretty terrible skies here, but good skies in Texas where the telescope is operating. So hello from Australia. So what is this? What is going on here? So this is me testing out the technology for my new upcoming virtual star party, and this is the base layer. This is the bedrock of this new system, where we are going to have at least one, but eventually many telescopes that we are streaming live from a telescope co-location in Texas. And so we're going to just roll through objects quickly, and that'll be sort of like the first layer, but then we're going to bring on more astronomers, and we'll have different perspectives, people who are seeing it in the daytime, and then we're going to bring on professional astronomers to help explain what we're looking at, and maybe bring on celebrities who have never looked through a telescope before, and we can kind of help them get even more excited about space and astronomy. And on Twitch, am I streaming on Twitch? I think I'm streaming on YouTube. Should I be streaming on YouTube? If I'm streaming on Twitch, that's really strange, because I have not set up my Twitch stream. So this is the M13 globular cluster in Hercules. And so this is actually a fairly easy to see object. You can see it a pair of binoculars. So for example, let's go see a comet. So, people have been asking me, oh, can we see the comet? So I'll show you how we do this. So I will search. I'll find the brightest comets. Comet A3, Chuchinshan Atlas. So we can see that it rose at 10:37 in the morning, and it sets at 11 o'clock, and it's 2 hours ahead of me, so it's 9 o'clock there. So it should still be visible in the sky. So I'll click center, and we'll go to the comet. There it is over there. And you can see this is the telescope. Literally, this telescope is actually moving to this location. And then we can see the live view, and you'll see sort of all these streaky stars as the telescope is moving to the location. Aaron Sokol, would this be able to respond within 24 hours to view? Yeah, absolutely. It's live. So yes. All right. So now we're in real-time mode. And so we are seeing the telescope, or we are seeing the view of the comet with a 10-second exposure time. It's not even the 10-second exposure time. Sorry, this is just literally just the ISO settings for it. Just like it's essentially video of the sky. And so I will start imaging, and we will make an image. And so now what I'm doing is I'm taking 10-second exposures at an ISO of 200. And for those of you who don't know how astrophotography works, essentially you are trying to get the longest possible exposure that you can. The more of an exposure that you get, the more data that you get. Now, so we've got that first image. That's a 10-second image of the comet. And so now it's layered on a 20-second image of the comet. So it's stacking the images on top of each other. It's trying to find the ones that have the data. It's trying to remove the pixels that are just noise. Every 10 seconds, you can see it gets like a little bit more obvious. It gets, the tail starts to show up. You get to see these features. And this is a 30-second exposure of this comet. So I can better center. So we just got so in that exposure, we got a satellite trail passing through the image. And that's a 5th one. So we'll just stop now. But if you want, we can come back. We can do a better version of it. So I'm going to end the image. And I will download and save. And then I can recenter the telescope. Yeah, absolutely. Yeah, we can totally do. So I can recenter, right? So that's the picture that I'm downloading. Oh, can I not? Oh, that's obnoxious. Okay. And so now it should be saved. All right. These are the kinds of things that you're here to help me figure out the bugs. So now I've got the image locally, and then I'm going to sync it to the iCloud, and I will give you all the link. So you can download it there. So that's the picture, and I'm going to download it as well. And then I will open it up. Right. Open with Paint. So then I should be able to close the other one. Oh, this is just, there's a lot to figure out here. Okay. So there, I guess that'll have to do. Okay. So there you go. There's the comet, and including a satellite trail. And check it out. You can see the, just the little bits of wispiness in the tail. So were you able to download the picture from the chat? I'm going to do this all automatically. So I just want to know that that's actually working. So you can, you can make this a wallpaper, but whatever. But what's amazing about this, and for those of you who've seen our star parties in the past, and just how long this takes, this is so fast. This is crazy. We can go so fast. So that was a 30-second exposure. So let's go see the Andromeda galaxy. So we'll just do M31. So I search. The Andromeda galaxy comes up. So now we'll center the telescope on Andromeda. And you can see all those objects that are there. Those are all things that we can look at if you want to. Yeah, so now we're moving. So these are all the constellations. You see there's the Bubble Nebula, the Iris Nebula. We'll take a look at all of those. Pac-Man Nebula. Some objects are really fast to image, like Andromeda. Others take a lot longer. So we'll sort of see how much patience people have for this. And, I'm still learning how long of an exposure I want to do, what kind of a, depending on the object. And some objects are just too small. Like this telescope setup is not good for planetary, like for doing Saturn and Jupiter. If you remember in the old star parties, we used to call it Saturn because it was so sad. So you can see that is the field of view on the telescope, is that little box. So we're not going to get the whole galaxy in that box. We're just going to get a chunk of it. And so here's the live view. And you can just barely see it. This is the kind of, if you own a telescope, this is kind of like what you see. And so if you're like, oh, I want to look at Andromeda through a telescope, what you're seeing right now, this is roughly what the eye sees. But now we'll take a picture. And again, we're going to take 10-second exposures at a 200 ISO. We can do a faster ISO that will make a sort of a grainier picture, but this works pretty well. And then we'll stack up the image for as long as you have patience. So, the telescope is 6 inches, so it's actually a fairly small telescope, but it's got this really great camera system on board. So if you look at it, I think I might have started the exposure a little too soon before the telescope had fully stabilized. So you see how there's like all those little streaks. So I think I'm going to ditch that and we'll start again so that we get a better image, because I want to make those streaks go away. So we'll discard the image and we'll start again. Okay. I don't think you have to have Apple Cloud. I think you should be able to just download the picture. So, let's see if we get the stars being, that's better. Okay. So now take a look. You can see sort of all of that haziness and cloudiness in the, sort of in the darkness there. So that's where the telescope is starting to, like, that was that first image. And so now it's stacking up more and more, versions of it. And over time, like people, when you see those like really nice pictures of Andromeda, in some cases, people have taken a picture for an hour, right? 2 hours, just constantly gathering more and more data. I'm doing 40 seconds. And I think, I'm pretty happy with how this looks right now. So yeah, that's pretty good. Okay, there you go. Let's wrap it up. 50 seconds of exposing Andromeda. So we'll stop the imaging and we'll move on, because I don't have patience for really doing the best version. So we'll download and save. Okay. And then it should show up in my images in a second. Yeah, there it is. Okay. Oh, this is frustrating though. Okay, I'm gonna have to fix the image. So it needs to be higher up there. So I need to move that. So I don't have to keep messing with it. Okay, hopefully that'll stay stable. Okay, so now I will point the telescope at a different target while we enjoy the one that we just took. So let's go look at the Iris Nebula, which is one of my favorites. So we'll go to the Iris. And so while that's happening, I will share the picture of Andromeda we just took. There's a lot of multitasking here going on. I'm going to try and figure out how to automate this. So there's your iCloud image of Andromeda. And let me grab mine. So if I close this, it should disappear. And then I can download it. So the moon isn't up right now. But I can. I'll show you. I took a picture of the moon just a couple of days ago. So now I can open that in Paint, right? And then it should pop in. Yeah, okay. There we go. Okay. So now while we were talking, we're on the Iris Nebula, and hopefully the telescope is stabilized again. So we'll do another image. And this may require a little bit of a longer image just to get a nice exposure. So stay tuned. No Starlink trails in that image. Well, because we didn't do a very long exposure, but you do a long enough exposure and eventually you will get the exposure. So this is going to be fun. So this is the Iris Nebula, and this is one of my favorite objects in the night sky. And what you're looking at is it's a reflection nebula surrounded by a dark nebula. So you've got this super bright star down in the middle, and then it's surrounded by nebula material, and that's why it all kind of looks very dark around it. But the star is so bright that the light is bouncing off of this nebula material and coming towards our eyes. But the reds and the yellows of that light are being absorbed by the nebula. And so what's left is the sort of the bluer tones. And so with this one, you can really see how the longer exposure makes a big difference, right? So we're looking at, this is now, you know, while I've been talking, while I've been delaying, we've gone through 60 seconds. And so it will look better and better and better. But I find this just gets kind of better after like 90 seconds, 2 minutes is probably a better amount of time to do this at. So let's see. So there's some other questions. Yeah. So I'm using it's called a Celestron Origin Telescope. I know I'm going to have to like put this up or have this on, you know, a bot that's posting into the YouTube comments, but it is it's a remote telescope in Texas. There's a company called, Starfront, and they provide telescope co-location, and they are they've set up a telescope for us to use for these star parties. So, can we do the Sombrero Galaxy? Sure. That sounds great. So this is 120-second exposure of the Iris Nebula. So why don't we stop it here? And we'll switch to the Sombrero if it's up. So I'll start the save, and then I'll share it to everybody. Okay. So that'll show up in my iCloud. So let's see if the Sombrero's up. Rises, transit, set. So it's already set. So it's set at 5:25. So we can't see it. It's already below the horizon. Virgo galaxies are seen in the spring. So unfortunately, we're going to have to wait until the spring to see it. But let's pick something else. And so we can do things like, let's do the fireworks galaxy. So that's the gist. So now we'll move. Actually, it's pretty close. Actually, it's pretty good. Okay. All right. I was going to give you that image of the iris. But clearly this needs a longer exposure because this isn't great. It's the kind of thing that we do with a 5-minute exposure. So the Horsehead Nebula won't be up yet. So there's the... So let me try downloading it. And so let's zoom in now because I can do that on my screen. There. Does that work? Yeah. Yeah, so the colors are more evident the longer the exposure. So we just did a very short exposure for this kind of an object. You know, if we did a much, much longer exposure, then it would be, you know, it would just look better and better and better over time. And, you know, with this kind of an object, you want to do like an hour-long exposure, but yeah, you don't have patience for that. So yeah, do you want to see a planet? Do you want to know why we can't see a planet? No problem. Oh right, we're gonna take an image of the fireworks. So let's do that first, and then we'll go and look at Jupiter. and you will understand why we can't do it. So again, this is what you'd see through a telescope. And then once you start to actually do a long exposure with a camera, that's when you start to see objects. So there's the galaxy. That's a 10-second exposure. No, because they're very small. That's the problem. This is a very wide field telescope. So we are setting up a second telescope that's only job is to do planetary. So this, and I'll show you. I'll show you what the moon looks like. Actually, I'll just share the picture of the moon so you can grab it in the chat if you want. It looks good. The moon looks great. Okay. So there's the moon. Close this. We zoomed in. So that was the picture of moon that I took a couple of days ago. So moon looks great. But that's all, like, there is no zoom, right? So if you want to like look at a little crater, I mean, I can zoom the picture like this on my computer, right? That's cool. But yes, these live images are being controlled by Fraser. But a telescope that's designed to do planetary stuff will actually have a much smaller field of view, and it'll just show you the moon. All right, I think we've had enough of the fireworks galaxy. That's like 140 seconds. So let's end that image, and so you'll see this one again wants a much longer exposure. It wants like a 5-minute exposure. But I'll download the image, and we'll see what we can do to kind of show it off. And then we'll go see Jupiter. No, it's not that Jupiter is too bright. It's just too small. So Jupiter rises later. Okay, we'll do Saturn. No problem. Saturn it is. And this is kind of complicated. So we're going to have to kind of mess around with it a bit. Yes, I did Andromeda. No, globular clusters look great. I actually started with the globular cluster. So we're still slewing. So there's Saturn. And Neptune's there too. Pretty close to Saturn right now. Okay. There it is. So why does this suck? So the first thing is that the exposure is too long. This is a 10-second exposure, and we don't want to do a 10-second exposure. We want to do something more like a 1-second exposure. So I will try to do that. And even a 1-second exposure is too long. So now we're doing 1-second exposures, and that's still too bright. So we'll try a millisecond exposure. Oh, snapshot mode. Okay, I gotta be in snapshot mode. See, these are things I don't really know yet. Okay, I'm in snapshot mode. On. Okay, there it is. Do you like it? Let's take a picture. Okay. Now let's save it. All right, save to my camera roll. Nice. I'll share it to the group. Enjoy. You've earned it. And I will see what we can do to blow it up in paint. Okay. There you go. So there you go. That's Saturn. So this telescope is not for looking at Saturn. This is the best we can do with planetary stuff. So we call this sad turn. But like I said, second telescope that's going to be streaming in the next couple of weeks, and then I'll be able to switch back and forth between the planetary one and the wide field one. So yeah, that's no good. Sad turn. So let's go back and do something deep sky. So I saw someone ask for the helix. So we'll get out of snapshot mode. And then let's do the helix. This is a planetary nebula. No, the Dumbbell. Okay. With a planetary telescope, would it be possible? Yeah, the difference is the focal length. So it, like, a 6-inch telescope can show Saturn just fine. It's the difference between the upcoming Roman telescope with a really wide field of view and the Hubble Space Telescope, which has a very, very small field of view. Different telescopes for different purposes. So with this one, we can see really wide fields of view. But we can't see little things like planets, unfortunately. Yeah, we can see the pillars of creation. That's in the Eagle Nebula, but that's for summer. Well, maybe we can still see it. Let me see. No, the planets look great in Hubble. Hubble has a very small field of view. The planets will look garbage in Nancy Grace Roman. Yeah, so we're going to have 2 telescopes. One for planetary and one for deep sky. Okay, so we're probably still jiggling around a little bit. So this is the Dumbbell Nebula. So we'll change the exposure again to 10 seconds. And we'll take a picture. Do you see it? Do you see it? It's right there. Can we see a wormhole? Only if one appears. Yeah, same. You can't see the Carina Nebula from your hemisphere. It's true. So there we go. So that is 10 seconds. Uranus will look even worse than Saturn. Yeah, we can do the double cluster. We'll do that afterwards. So it is stacking in real time. So we're doing 10-second exposures, and it's stacking in real time. It's getting better and better and better with each exposure. So this is a 30-second exposure of the Dumbbell Nebula. No, planets won't look good in the Rubin telescope. No, I wouldn't be able to see James Webb. Yeah, I could take a picture of Uranus, and it would just look like a little blue dot. No, we could see it. It just wouldn't be a big blue dot. It would be a very small blue dot. All right, that'll do. 60-second exposure of the nebula. All right, we'll wrap this up. And then somebody wanted the double cluster, so we'll do that. Okay. This is one of my favorite objects. But I think I say this a lot now. Oh, right. Double click. So that's in Perseus. There's the link. No, can't take a picture of the Earth. Well, this isn't the star party. This is me testing out the technology. Has nothing to do. Well, I mean, the star parties will have this, but there'll be other stuff layered on top of it with a better layout and all this. I just, I like to do things live. And do it live. All right. So let's zoom in. Zoom and enhance. That's pretty cool. So that's a picture we just took. 60 seconds. So this is a star like the sun that has died, and it has puffed out its outer layers as it died. All right, let's take a picture of the double cluster. It's the multitasking I'm going to have to figure out here. And so I can recenter it, which is kind of cool. So I click reframe because I want more. I want to see both clusters, and then it'll actually move the telescope to center it the way I want it set up. Right? Yes. So now it's moving the telescope. What have I done? There. Okay. So now it has a better framing in the screen. And then I'll take the picture. And clusters, you don't need a very long exposure. So we can do it really quick. Like 30 seconds. Does the scope have a rotator? So that's 10 seconds. And we'll come back around and we'll do we could do the M13, the globular cluster in Hercules. It's a Celestron Origin telescope. Is the telescope. And so this is no nebulosity, but there's lots of stars. And you can actually see this with your eyes if you know where to look. The blue, the different colors in the planetary nebula sort of are based on different kinds of chemicals that are ionized. So I think it's oxygen creates blue. So you're seeing clouds of oxygen from the star. Okay, let's wrap this one up. And then we'll go to M13. That. And then M13. I gotta sort of remember, like, there's so much stuff that's in the sky. All right, so we'll go to the cluster in Hercules, and then I will share the picture that we just took. That's the double cluster. Okay. Cool. That's really cool. Okay, so can you see the globular cluster in Hercules before we start doing the actual image? So we'll do an exposure, and this doesn't take long at all. Like a 30-second exposure will be plenty. But how many stars are named? About, I don't know, 600, 700? Focus looks okay. Someone was saying the focus looked a little soft, but it's okay. That's 30 seconds. Fraser got to control James Webb. Yeah, that'd be great. Can this pick out a single star? Yeah, it can. Oh, great. Hey, Ronald. Okay, that'll do. I'll share that with you in a second. I mean, there's a bunch of stuff that controls the sharpness. It can be just how, if I didn't let the telescope jiggle before I started the exposure. Okay, we need a new target. So let's try and do some galaxies. So these are all the choices. These are all the things that I could see. So let's do Bode's galaxy. That would be good. Okay. And there's your M13. Who knows? I mean, we're just like, we just got access to this one. So, will we someday get one in the southern hemisphere? That'd be amazing. It all depends on whether Starfront decides to put them in the southern hemisphere. So there's about 1 million stars in that. Yeah, we can do M51, I think. It should be up. So we'll do M51 too, which would be nice. Can anyone use a remote telescope? Yeah, people can use remote telescopes. I mean, this is a telescope that was set up specifically for us, for me to use to do the star parties with. And so, the company that does this, that hosts these telescopes, clearly this is product placement for them. This is promotion, Starfront. So we're going to put their logo up and make sure that they get a lot of thanks for giving access to this telescope. Yeah, I can point it at a random spot. It's located in Texas. I don't know exactly where it is, but like in really dark skies, really far away. Trevor from, oh man, what's his so the Astro Imaging channel, he did an episode about Starfront. So you can start to see the galaxy coming in now. Yeah, I'm at Starfront. Well, I'm not at Starfront. The telescope is at Starfront. Hoag's object? Yeah, we can try that. I don't have any stars in Western Canada. I just have clouds and rain. Rain and clouds. Name it Fraser. I have an asteroid named after me, right? I wonder if we could find it. Yeah, Trevor Jones' Astro Backyard. That's it. So he just did an episode about Starfront, and so you can see just how cool the facility is at Starfront. So someone could walk over the... Yeah, if you go to Starfront, you can actually see the... Let me see if I can get the picture. You can see all the telescopes. And they're actually setting up a telescope. Yeah, here we go. They're setting up a camera so we can see just this telescope. And then we can watch this telescope move. Okay, let me close that. Paint. So those are the telescopes. I don't know if you can see them. And there's a bunch of barns. There's like 6, I think. I don't know how many they have. And these are all the telescopes in the building, in the one that we're in. Okay, let's stop this image of Bode's. Yeah, we'll see what's in the... I think the core of the nebula, the core of the Milky Way is below the horizon. We'll take a look. But I'm pretty sure... Like, we'll try the Eagle Nebula. But I'm pretty sure it's gone. Okay. Gotta wait for summer. Sets at 10:57. Oh, maybe there's a chance. So you're saying there's a chance. Let's see. I hope I don't break the telescope. It's going to be very low on the horizon. And Pleiades should be up. Yeah. I took a picture of it the other night. Just saying there's a chance. This is pretty cool, actually. That's M81. Clearly wants a longer exposure, but you can see the sort of spiral nature of it. Okay, so this is no exposure. So let's start gathering an image. So if that's nice. So the stuff in the center of the Milky Way, this is in the heart of the Milky Way. So if a lot of these are available, then we'll rush through a bunch of them before they set. There it is. And 10 seconds, you can already see the pillars of creation. Yeah, so the North American Nebula is not great in a short exposure. I've tried doing like a 5-minute exposure for the North American Nebula, and then it starts to show up. But so we need to do longer exposures for that kind of thing. You're in... no, we can't see the flag on the moon. So we're in the Sagittarius? Is Eagle Nebula in Sagittarius or just outside of it? Yeah, Space Telescope would be great. Sold. I'll take one. So that's 70 seconds. It's not going to get a lot better. Okay. I mean, it would look better if I did an hour-long exposure. So we'll stop here, and then I'll share it. Someone's asking about Andromeda. We did Andromeda just a couple of minutes ago. So I'll just reshare the picture. There were satellites. You missed it. We had a satellite, just not in this picture. All right, so let's see what else is in. Like, we should be able to do some other stuff that's in Sagittarius that's nearby. So let's do the Omega. Okay, we'll do the Omega Nebula. Which is just nearby. Why we gotta go the long way? Okay. Okay. There's the Eagle. And let me download it. And we'll look at the pillars of creation. There's a satellite trail. So right along the top there. Do you see that? Pillars of creation. Okay, we're going to take some images of the Omega Nebula. And we'll go to Pleiades. Can probably still see the comet too. We actually caught the comet earlier on in the session. Here's the picture we took like half an hour ago. for those of you who are just joining, I guess which one is the comet? Could I see an extragalactic supernova with this? Sure. Yeah. So there's the comet we took earlier. I don't know how the origin works with stacking. So in theory, you can download all of the separate raw images and then you can do more control over how you stack it. But, you know, we're just trying to give you the gist of space, not actually try to take really nice astrophotography. So I don't care if there's satellites going through my images. Now there should be one more image. I'll grab the Omega Nebula. Sombrero has gone below the horizon. The Veil Nebula is out. Yep, we'll grab the Veil Nebula too. All right, so I should be able to get. So there's the Eagle. So see if we can get to the lagoon. I don't like my chances. It's pretty low. What's its... Okay. So too low. So I can't get the Lagoon Nebula. So let's go for Pleiades. M45. No problem there. I'll bring up the Omega. We'll zoom in. That's pretty cool. Okay, this one we're going to have to recenter the image because it's a fairly wide field of view. Let's see. What do we want to get? I'm not going to be able to get all of it. Okay, we'll just have to go with this. All right, let's start. So the cool thing about Pleiades is you get the like the nebulosity around these young stars. Pete's astrophotography. So this is a celestron origin at the co-location at Starfront, and they are letting me use a telescope of theirs, which is awesome. So we're going to be doing the star parties every week, and so this is the sort of base layer of doing our astrophotography. So we're going to bring on astronomers to talk about the objects that we're seeing. We're going to bring on more astrophotographers, and maybe they're going to be working with their own rigs. And then at the same time that we're doing, I'll be doing some imaging. So I probably won't even be operating the telescope. We'll probably have somebody else on the team operating the telescope so that I could just focus on being the host. But I just wanted to test and see if it was going to work and how fast it is. And it is like 5 times faster than when we were doing star parties before. Like when we used to do star parties, we would do an hour and we would get like maybe 20 images in the hour. And I'm just hammering through images here. This thing is so fast. So Yeah. Yeah, Heart and Soul Nebula, they don't look great with a short exposure. So a lot of the stuff that you're talking about, the Heart and Soul Nebula, the North American Nebula, the California Nebula, the Pelican Nebula, they look good after a 5-minute exposure. And that's where this thing, it's a good camera, but it's a fairly small telescope. And so it doesn't grab a lot of light compared to a RASA. So, we can definitely go to take a look at something like the Pelican Nebula or the Heart and Soul, and you'll see it's just, we want to do a 5-minute exposure, a 10-minute exposure before it starts to look really good. So, and it's too bad because this is like, Pleiades is too big to fit in the field of view. Absolutely perfect to do your taxes with. No, we haven't tried M33. We'll do it. Sure. So let me stop Pleiades. And then I will share the image with you. Okay. And let's try M33. Yeah. Should be up. Okay. There's M33. No, sorry, that's Pleiades, M45. But it's just a little piece of it. Like if I wanted to be fancy, I would have to take a bunch of different images of different spots of it and then put it all together. The imaging software just comes with the telescope. So I have really very little control. It's the built-in app that comes with the Origins telescope. And so it's not a great, it's fast, which is what I need. So, so no, we can't get any good views within the solar system, but we're getting a second telescope set up that will. So we're going to have 2 telescopes. We can just swap back and forth between the deep sky one, this one, and then the planetary one. All right, let's get M3 Triangulum. Oh, this is going to be good. So again, this is kind of what you see live, although it's like a little bit, like if you're looking through a telescope, you just can see just the faintest view, but it's only when you start doing a long exposure do you actually get a chance to see it. How long are we at? That's an hour. Okay. I'm going to probably the last image, because this was just not supposed to happen, but we'll leave it up so people can check it out. And then probably next week we start with the virtual star parties again. But we just have to figure out how to do this. The company rents out piers for telescopes. So you go to Starfront. If you just do a search for Starfront, and so you can have your telescope mounted in their facility, and then you get really nice sky, 24/7 tech support on your telescope, things like that. The neighbor's bathroom. So that is 70 seconds. So you can see, like, if I wasn't doing this for a live audience and I was just trying to take pictures for myself, then I'd be doing 5-minute exposures, 20-minute exposures, an hour exposure. There you go. Star Pictures Miami is at Starfront with a sea star. That's awesome. So the hope is like there's so many astronomers who are actually out at Starfront as well that I'm sure we're going to start, I'll have them show up while they're, because we're all going to be observing together. So we'll do some star parties with a bunch of stuff. I don't technically own this telescope. Starfront owns the telescope, but obviously this is marketing for them, so they're letting me use a telescope. Am I going to do one with a long exposure? There you go. A bunch of people are at Starfront. All right, let's wrap this up. And we'll share it. And then I think we'll wrap it up for tonight. But then we'll see you all tomorrow for the question show and astronomy cast. Yeah, 20-minute exposure. Who's got time for that? All right. No, we need astronomers who can go fast. You don't know that I didn't show you aliens. There could have been aliens in any one of those pictures, just really far away. Okay. This is nice. This is a good picture to end on. So this is M33, the galaxy in Triangulum, and this is the other large galaxy in the local group. So we looked at Andromeda, which is the big galaxy in the local group. There's the Milky Way, which is the other one, and then there's M33, which is the third big galaxy. And so Andromeda, the Milky Way, and M33 will one day merge into this giant elliptical galaxy. All right, that's it. That was an hour of telescope observing. We saw like 20 odd. This is incredible how fast this whole setup is. So hopefully, it'll probably be longer, probably more like 2 hours, but we'll see. We'll take requests. We'll have experts. We'll talk about space. We'll answer your questions about space and astronomy. We'll teach you how to get into amateur astronomy, what gear to pick, all that kind of stuff. So yeah, star parties are back, man. All right. Thanks everyone. And we will see you all next time.